Hi, this is John Johnston, President and owner of Irrigation Accessories Company, better known as IACO. IACO was founded in 1962 by William H. Stout. We've been manufacturing quality products for the agricultural irrigation industry ever since. We've been manufacturing Boombacks for 30 years. Welcome to our webinar. Let's get started. I'm going to be talking about two different technologies utilizing Boombacks. The first is what we call dry wheel track solution. The second we refer to as innovative boom technology. First, let's talk about the products that creates the dry wheel track solution. Part circle sprinklers and Boombacks. That's what allows us to create the dry wheel tracks, keeping the water off the towers. What are Boombacks? Sometimes they're called offsets. Boombacks are add-on accessories for pivots and linears to relocate or offset the sprinkler 10, 12, or 15 feet away from the center line of the span. As the industry leader, we have Boombacks to fit any pivot or sprinkler. Whether you're retrofitting an older machine or looking to install the newest pivot available, we make a Boomback that fits your needs. All three of these sprinkler manufacturers make part circle sprinklers. Senegar and Comat only make what's called a fan spray. It has a static plate. The stream hits that static plate and spreads out like a fan. Nelson, however, makes two sprinklers that have a movable plate. That movable plate allows for a greater throw distance, which lowers the average application rate, which allows you to get the water into the ground more efficiently. So that's the two we're going to focus on. The part circle spinner and the part circle rotator. For those of you who don't know what a part circle sprinkler is, it's a sprinkler that basically throws 180 degrees in one direction. That's why with these sprinklers and Boombacks, we can keep the water off the tower and out of the wheel tracks. Now, the first thing we ran into with a part circle sprinkler, if you think about it spraying 180 degrees in one direction, you get what's called side force. It's going to push back, so you cannot use it on a piece of hanging hose. The other problem we ran into was called rotational torsion, especially on the part circle rotator. It has a resistance drive on the spray plate, and that gives it the greater throw distance, so it makes it a better sprinkler, but it wants to rotate around. That rotational torsion tries to spin that sprinkler around, and we don't want that because we want to control the direction of that sprinkler spray to keep it off the towers. So the first thing we came up with is a side force control fitting. This is inserted up inside the hose of a hose boom, and then the hose is cut short and it's encapsulated in the steel tubing on the outer side. That's what gives it that side force control, so it can't blow back. And then we came up with a piece called the torque clip. The torque clip captures the screw clamp and keeps the sprinkler from rotating around. Now that torque clip also did something else for us. As you can see here in this picture where we've captured that screw clamp, if you think about screwing a part circle sprinkler and regulator onto a standard rigid drop and you tighten it all the way up, it may or may not be pointing in the correct direction. So then you're forced to either over tighten or under tighten to get that spray pattern in the correct direction. Well, now with the torque clip, you can tighten everything all the way up tight and then just loosen that screw clamp and aim it in the correct direction, tighten the screw clamp up. Now you can also see this assembled piece here, this black little piece above the sprinkler, that's part of the side force control fitting. There's a piece of aluminum tube that goes up inside the hose boom, and you can see where it's encapsulated. And that is what gives it the rigidity needed to control that side force. Let's look a little bit more at the hose boom. This is what we call the traditional configuration. Now the traditional has the hanging piece of hose. It's a fully hose lined boom, so you'll never have any rust flakes plugging your nozzles. And every hose boom comes with all the parts necessary to convert it to what we call the part circle configuration. And the hose boom is the only boomback recommended by Nelson for part circle sprinklers. Let's look a little more detailed at the hose boom. We've been manufacturing boombacks for 30 years, so when we wanted to come up with a new style boomback, we wanted to look at any issue anyone's ever had with a boomback and address it, and we think we've done that fairly well. First, we re-engineered the bracket so it clamps tight around the span. We don't want that slipping at all, and it doesn't now. It's precision stamped, it's robot welded, has slotted U-bolt holes. It's hot dip galvanized. That used to be a painted bracket, but now it's a galvanized. It has easier assembly, superior clamping, custom diameter U-bolts. Originally, we just used U-bolts that was off the shelf, and they fit really tight over the tubing. So now we have custom U-bolts made to our specifications. That, along with the slotted U-bolt holes, makes it really easy to install. We have heavy-duty 1-inch bracing. That used to be a 3/4 inch brace. Larger diameter tubing. Now we did that to encompass the hose, but the other side benefit of that is it's far more rigid than any boomback we've ever manufactured before. Comes with a factory bend. Every hose boom comes with the torque clip and the side force control fitting, so you can use it in the traditional configuration or easily convert it to the part circle configuration to control the side force and that rotational torsion. We have a chafe-free flare at the end of it where the hose comes out. It's fully hose lined and it's factory installed. When you get a hose boom, the hose is already installed inside the tubing. The other thing the hose does for us, it gives us built-in dampening. With the part circle rotator, with that resistance drive plate, there's vibration in it. Well, now, if you imagine this in the part circle configuration and you have the side force control up inside the hose encapsulated by this tubing, it's like a motor mount in your car. You have the aluminum of the side force control fitting on the inside, then the rubber hose, and then the steel tubing on the outside. So we like to say it's not just a piece of tubing. A lot of thought and engineering and development went into this product. We used every bit of knowledge we had gained over those 30 years of manufacturing boombacks. Another interesting feature of the hose boom is you can install it inverted. A lot of people who are growing corn want to keep the sprinkler spray pattern above the canopy, and they're reverting back to sprinklers on top of the pivots. Well, now you can put those up top white plate rotators on a boomback. It's the same boom, it's the hose boom, it's just an inverted installation. So with this one part number and this one product, the hose boom 15 foot, you get all three of these boombacks. And we make it for every pipe diameter that's being manufactured today. And the hose boom works with any sprinkler on the market, whether you're using an IWOB or an orbiter that needs a piece of hose hanging, or you're using a part circle rotator that needs to control the rotational torsion and the side force. You can do it all with this one boomback. We also manufacture what we call the double hose boom. Now the double hose boom gives you the ability to split your spacing. We had a grower in Zambia that had 10-foot spacing on their machines, and they weren't getting the uniformity they wanted. They were getting streaking. So we came up with this double hose boom, which is 2 hose booms off the same outlet. Now, since the hose booms have a hose connecting it in, you can use a longer lead hose and split that spacing. We call it the spacing split kit. So we were able to emulate 5-foot spacing on the end of their machine using the double hose boom. And it gives you a full 30-foot spread. We make it just as the hose boom for any pipe diameter that's on the market today. And we split it off the outlet using a double gooseneck. Another product we make is called the Corn Boom 10-foot. Those growers who are growing corn that have the up top sprinklers on their pivot, they may want to use a part circle sprinkler at the towers to create that dry wheel track. But you still want to keep that spray pattern above the canopy. Well, that's what we manufactured this for. It has an upward trajectory coming off the span that lifts this sprinkler height to match what a sprinkler on top of the pivots would be. Again, every pipe diameter on the market and every corn boom comes with the side force control fitting and torque clip. So you can now have a dry wheel track system on a pivot where you're utilizing up top sprinklers. Here's a video of the corn boom in action. Feel free to go to our YouTube channel. Just go to YouTube and search on Boombacks, and we have these videos uploaded, or our website at boombacks.com. Now, look at the wheel track that we've created there. We have crop growing right up to the tire line, and we're actually running over crop instead of having that ununiform streaking at the towers. Now let's talk a little bit about the setup of the dry wheel track solution. What we're looking to do is eliminate ruts, stop getting stuck, eliminate downtime, reduce cost of repairs, and increase the number of revolutions. That's a critical one. A lot of times you'll have ruts that get so deep that you can't do those final 2 or that final 1 revolution, and your crop suffers for it. Drool is a term commonly used for sprinklers. If you have a sprinkler that has a plate that's being held by a cage, when that sprinkler hits those arms of that cage, a little bit of water drips off the bottom of the sprinkler. That's referred to as drool. Well, if that's drool, if you're watering the tower and your tires, I like to call that slobber. Just think about the water that's running down that structure, that's running down those tires right into your wheel track. So we wanted to eliminate that. We wanted to stop watering that structure, but not give up much on the uniformity end. So this is what we came up with. This picture you're looking at was one of the first pivots we ever set up with dry wheel track solution. It has 4 boombacks at the tower and then 4 part circles spraying backwards. This particular pivot in this picture has boombacks forward and backward, and it's set up to be automated so you can run it in either direction, and the leading ones get shut off. We'll talk about that a little bit more later on in the presentation. But after we set up this machine and we turned it on, there was a photographer there with me, and I said, you have to get that shot because it shows what we're looking at here in this graphic. You can see visually on the ground from that pivot. You can see those dry wheel tracks that we've been able to create. And something we learned was down in California. We had a grower down there that had really bad rutting problems, and we set up 4 boombacks per tower, but a lot of you know that the outlet spacing isn't always equal around the tower. Sometimes you have that one outlet that's really close to the tower or even right over it. So this first sprinkler was hitting the tires. Now down in California, they have really sticky dirt. It's really heavy clay, and they really have absorption rate problems. So just by wetting that tire a little bit, it acted like a snowball rolling through the snow, and it just kept getting bigger and bigger with mud. So what we came up with was we moved that first full circle sprinkler over an outlet, put another boomback in, and put another part circle on. So our general rule of thumb is we want to be 20 feet away from the center of the tower before you put that first full circle sprinkler. The rigid hose drop is another product I want to talk about that works with part circle sprinklers. Now this is less expensive than a boomback, and a lot of times we'll have people using it on linears. They want to keep the water off their generator, but they want to grow the crop up as close to the tower as they can. So we came up with what we call the rigid hose drop. It's fully hose lined, just like the hose boom. It has the side force control fitting, the torque clip so we can use a part circle rotator and we control that rotational torsion. It has a 40-degree bend. Why we did that instead of just making a straight piece of tube was, if you think about rigid drops on a span in the old days, as you got to the tower, the arc of that span didn't allow you to put your drop perpendicular to the ground. With this 40-degree bend, you just loosen up these U-bolts and you can put that drop perpendicular to the ground. Another good use for this product, and this is probably where we sell the most of these, is a polyline machine. Since this clamp holds all the weight of the drop and it's tied in with a hose, you can use this on a poly machine. There's no stress on the outlet. Has the built-in dampening, just like the hose boom. And another thing is, you can put it anywhere as you want in the span. You're not tied to where the outlet is. Now, those guys with linears that have generators that want to water right up as close as they can to that generator but not spray it, now you can. You just use a longer lead hose in. Doesn't matter where the outlet is, you just use a longer lead hose and you can place this drop anywhere as you want on the span. Now here's what the overhead looks like with just regular drops. Now we put the rigid hose drops. Again, we do the same thing, the first two outlets on either side of the tower. Now you can see you're going to lose some in uniformity. This way there's no watering behind the tower. Now you get a lot better uniformity with the Boombacks, but if you have a linear or a wiper machine and it's not that critical for the uniformity around the tires, this is a good way to go. Another thing you can do is rotate those sprinklers in a little bit to try and close it up behind there. Now still, we would recommend you use hose booms and recapture all that crop around the tire, but sometimes some growers don't want to have the expense, and this is a less expensive way to go to help with your wheel tracks and rutting. The rigid hose drop comes in every pipe diameter size, works with any part circle on the market, although I mostly talk about the Nelson part circle rotator or the part circle spinner. The fan sprays or the LDNs from Senegar or the part circle Comet precision spray also work with this product. Now this is a company we've teamed up with where we're trying to make that automated system that I mentioned earlier. So you can have it be automated. You put Boombacks forward and backwards with part circle sprinklers on, spraying away from the tower. And this system, it uses two different switches and regular valves, and we can make it automated. So no matter which way you run your pivot, so if you have that wiper and you want dry wheel track solution, or if you have a linear, or if you just like to run your pivot in either direction and not have to go out and manually turn valves on and off, this system will do that. It's still in development. We're probably a few months away from having an announcement, but we're really close. So let's take a look at what that might look like. So here's a linear moving in one direction. The fluid pouch system shuts off what was the trailing, and then they become the leading, and now you're still just watering behind the machine. It consists of several different switches. We call it the Boom Pilot and the Pulse switch. Say we're probably going to have an announcement on that fairly soon. Now let's talk about innovative boom technology. We had a carrot grower back in 2005 down in California who was struggling to get carrots to germinate on the end of the pivot. Carrot seeds are planted just barely below the surface, and down in California the ground is so tight and hard, out on the end of the machine where you have larger nozzle sizes, it was just washing away that seed. They could not get it to germinate. So what we came up with was Boombacks on every outlet and opposing directions on the last third of the machine to lower what we call the average application rate, or sometimes referred to as the instantaneous application rate. and it worked very well. By lowering that, we stopped that washing away the seeds. They were now able to germinate the carrots with pivots, and they started buying a lot of machines and converting a lot of their fields. They could now be automated. So after 3 years, I went down and interviewed. There was 2 different growers down there using them at that time to see what results they were getting. And this is what they told me. 33% water savings, 37% increase in yields. They had an increase in crop quality, increase in crop uniformity, and runoff was practically eliminated. At that point, I realized we had done more than just create a carrot germinating machine. We've come up with a more efficient way to irrigate with pivots. And why is it so important at the end of the machine? Because that's where most of your acreage is. If you look at this graphic, you see there's only 2 acres under the first span. You have 62 acres under the last 30% of the pivot. So it's really critical that we get that right. That's where the bulk of your crop is coming from. Here's a cross-section of a pivot using traditional drops. Now we're going to add Boombacks on there in the opposing direction, and we've increased that wetted footprint to 66%. So what does that mean? If you take 2 pivots moving at the same speed and one has Boombacks and one just has traditional drops, you can see it takes longer to pass the same point. We're not putting on more water. We're just changing the amount of time it takes to put the water on. That's what lowering that average application rate means. We've increased that soak time. We've given the ground time to absorb the water we've just put on. That dotted line being drawn, that's infiltration rate of soil. This particular soil happens to be based in Idaho, but most soil is the same. Here, this is time on the bottom part of this graph. And as you can see, when you start off, the ground is dry, so it has a higher absorption rate. But as we put water on, that infiltration rate flattens out. Because you can imagine that as that ground gets wetter, it's not going to absorb as much water. Now let's look at that same pivot moving at the same speed, but we put Boombacks on. Again, we didn't change the amount of water we're putting on. We've just changed the amount of time it takes to put it on. So you see this is a lot flatter curve. We've pulled that time out. If you grab this point and moved it back to here, it's the same amount of water. Now anything above this dotted line is potential runoff. Not all of it becomes runoff because you have ponding or puddling, so some may still get absorbed in, but it's potential runoff. So we've decreased that volume of potential runoff considerably just by adding Boombacks and flattening that curve out. Here's a quick graph of if you have a 20-foot diameter sprinkler compared to a 45-foot diameter sprinkler, you've decreased that potential for runoff. But take a 45-foot diameter sprinkler and put Boombacks on, and you've really decreased it. You've really flattened that curve out. Like I said, this dotted line it may move up and down this graph depending on what soil type you have. If you have clay soil like down in California, you can imagine this dotted line would be up higher. But they all follow basically the same arc. When it's drier, they can absorb more, and when it gets wetter, that flattens out. Here's that overhead of traditional drops again. Now we're just going to add Boombacks on there. Again, we haven't changed the amount of water. That's still the same amount of water that we're putting on. And we've just changed the amount of time it's going to take to put it on. So we lower the average application rate, which gives you that increased soak time, but we also lowered the application intensity. Some people refer to it as the instantaneous application rate. If you think about this overhead here, here's the green where the drops are, and the blue is where the booms are. If you just turn that pivot on for a second, that's where it's hitting. Now, anywhere it's under the pivot at any given time, if you talk to the sprinkler manufacturers, 5 sprinklers should be hitting any point you pick under here. Now just think about that getting hammered by 5 different sprinklers. So what we've done is spread that out. So that same amount of water is over a bigger area. So now we've lowered that application intensity. The thing that does for us is reduce seal soiling. If you're in an area where you have really tight soils and you have that soil sealing problem, then you know what I'm talking about. Once you seal that soil, you're not going to break through that until you till it again at the end of the season. You can seal the soil early in the season, and then you're not going to get water into the ground no matter what you do after that point. So it's really important that we look at that application intensity or that instantaneous application rate. Again, we haven't changed the amount of water we're putting on. The overlap even remains the same. This is the same amount of water, just taking longer time to put it on. Still covering the ground, exactly the same. Let's look at a normal pivot going at normal speed with drops. Say we're looking to put on 1.25 inches. Took us 48 minutes to pass. Now, if everything's working fine and you don't have a runoff problem, then you're all set. That's set up perfectly. But what if you do have that runoff problem? Now, that water's not going to the crop where it needs to go. It's running off into the stream. If you can visibly see that water running off, then you're distressing your crop. You're not getting the water into the ground from that pivot the way it was designed. So what most people do is they see that runoff, they think, okay, I'm going to speed up my pivot. And then they'll visually see less runoff. But you didn't solve the problem. You're still not putting the water into the ground. You've just put on less water. The average application rate is not controlled by the speed of the pivot. The average application rate is something that's calculated no matter if the pivot's moving really fast or it's not moving at all. That's the average application rate of that pivot. We're going to get into that a little bit in a minute, but most people think, oh, I'll speed up the pivot and I'll change that average application rate. No, you do not. All you've done is decrease the depth of water you're putting on, because you can now see we only put on 1 inch in 36 minutes. So we put on less water. We still have the same problem. We're still not getting that root penetration that we're looking for. So let's take that in the original example, not a speeded up pivot. All we did was put on Boombacks in what we call innovative boom technology in opposing directions on the last third of the machine. We've lowered that average application rate. We still put on that same 1.25 inches, but it took us 72 minutes. It took us longer time. So that increased soak time gave us that increased root penetration. Now we're getting all that water into the crop. If you think back about that first slide where I said they had a 33% savings in water, 37% increased in crop yield, increased crop uniformity, because now the water is going where it needs to go. It's getting to that root zone. That's how this translates to all those increases in your crops and your decrease in water usage, because the water you're putting on is going where it's supposed to go and it's doing its job. Here's the formula for the average application rate. This 72, that's a static, that's part of the formula. So it's flow rate times the distance from the pivot divided by 72 times the coverage, that's the sprinkler throw diameter in feet. Let's look at a real world application of that. Here we're going to use a rotator with an orange plate, 20 psi, 9 feet. We got a 72 foot diameter. And this is just on drops. We got 1.5 inches per hour. Here's where you can see that formula. Here's your 6 gallons per minute per acre. Here's your distance from pivot. We just looked at 1,300 feet. This is the constant, the 72, and here's your sprinkler coverage. Now let's take that same example, and all we're going to do is add Boombacks to it. Now you can see This 72 went to 102 because of the extra spread of the Boombacks, 15 foot in each direction. So what did that do for us? It lowered the average application rate. It's a 33% decrease. That gives us that extended soak time. We're still going to put the same amount of water on, takes a longer time to put it on is all. And that's what we call innovative boom technology. We had a study done, and it was a really simple study. We just wanted to know what's the difference in runoff to drops to boombacks. We didn't look at crop growth or water usage or anything else other than we wanted to see what the difference in runoff is with drops compared to boombacks. And this is what we came up with. This is down here, these 1 through 5 are irrigation events. The first event, it wasn't a significant difference. It was 3%. We had 3% more runoff with drops than we did with boombacks. But remember that curve with that infiltration rate, when the ground's dry, it can absorb more water, but it quickly flattens out. By the 5th event, we had a 24% difference in runoff. We had 24% more runoff on drops than we did with boombacks. And this was a study done by Dr. Troy Peters, WSU, in Prosser, Washington. Here's a video of a pivot that's not far from us in Washington State. I believe this was potatoes they were growing. Now this particular grower we worked with Nelson on, where Nelson was doing some testing of some sprinklers, and we put boombacks on one of their machines in innovative boom technology. Now Nelson was doing the test for their sprinklers, but what happened was that grower realized all those things that the carrot grower realized, the decrease in water usage, increased yields, increased crop uniformity, right down the line. So now every year they come back and convert on their own 3 to 4 pivots. So their goal is to get this system on all their pivots. Now, if you look at this first part of the pivot here, where we don't have the boombacks, now this would be where the smaller nozzle size is. You can see that that application intensity looks pretty high right there. A lot higher than what you are seeing out here with the boombacks. And these out here have a larger nozzle size, because you all know you go from small nozzle to a larger nozzle to make up for the speed of the pivot out on the end. So you can visually see the lower application intensity or the lower instantaneous application rate on this pivot, even out here where the larger nozzle sizes are. Just going to let that run for a second. And again, you can go to our YouTube channel. Just go to YouTube, search on Boombacks, or go to boombacks.com and see our videos out there. And also, we have a lot of other information on the website. The study that Dr. Troy Peters did was called The Efficacy of Boom System in Controlling Runoff Under Center Pivots and Linear Move Irrigation Systems. I know that's a mouthful right there. And it was published online. It's in the ASABE Technical Library, Volume 30, Issue 5 of the Applied Engineering and Agriculture. Or you can go to our website and download a copy. Just click on the Technologies button and go to Innovative Boom Technology, and off to the left you'll see a PDF of that study, so you can download that and read the whole study yourself. I want to quickly mention another product we make that emulates what we call innovative boom technology. Now, it isn't as efficient as our boombacks because you're only getting a 60-inch spread, but Seneca came up with a product they call the truss rod hose sling to spread the water out. And when we saw this product, I thought, at the tower, you don't have that truss rod at 60 inches away. That's only at the center of the span. So I came up with an inexpensive product called the Sling Finger Boom. Now, I know this is tough to see right here because it's a pretty small graphic, but this is the overhead if you are using the truss rod hose slings and you don't use the Sling Finger Boom. Now you look at this graphic below, and this has 4 Sling Finger Booms on each side. You can see we've uniformed that pattern throughout the machine, even across the towers. Again, it's available for any pipe diameter that's on the market. It can be used with the double elbow, the 125 degree. We manufacture our own aluminum elbows in 125 degree that it would work with that too. We do not supply the truss rod hose sling, but we do supply everything else needed. Here's our website again. Now, we have more than just those videos that I showed you. We also have assembly videos out there. We've got a lot of questions about how to assemble our product once you get it. People were concerned that it was going to take too long. Well, we do it in real time. If you use a little forethought and line things up and do some pre-assembly, it doesn't take that long at all. You can see us do an assembly of a hose boom in real time. Also has our contact information out there, so you can give us a call or email us with any questions. Let's do a quick product summary. We talked about the sling finger boom. It works with the Senegar truss rod hose sling, an inexpensive way to emulate innovative boom technology at only 60-inch spread. The rigid hose drop works with polyline machines, can be used on linears. The corn boom, if you're using up top sprinklers on the rest of your pivot, but you still want to have dry wheel track at the towers, now you can. This product works with any part circle sprinkler on the market, including the part circle rotator and the part circle spinner. The double hose boom, again, this is tied in with a hose, so if you have really wide spacing and you want to emulate a narrower spacing system, you can do that. And then, of course, our hose boom 15-foot. This is our #1 selling boomback. And the one part number, that MST HBR C17 you see right here, gives you all 3 of these sprinklers. That's why we like to say one boom does it all. So thank you for listening to our presentation. And remember, if you're going to a dealer, a distributor, or an OEM, ask for Boombacks by IACO. There are other people out there manufacturing Boombacks. We think we make the best quality Boomback on the market. And if you want the very best, insist upon the hose boom. Thank you.